Hey guys, welcome to a new ChronoLogic live stream. I'm Joseph here. I'm a developer at ChronoLogic, and today we'll be going through some of the major differences we have in between the Ethereum Alarm Clock and the Chronos Protocol. So we have been getting a number of questions from our audience and from our community. Some of them might not find a very clear distinction and difference between the Ethereum Alarm Clock and the new Chronos protocol that we have been working on. So the topic of this live stream is just to go through some of these major differences and compare them side to side to see how they compare. So we are very excited to be working on this new Chronos protocol, and we are very excited to be basically at the end of the roadmap in delivering the Ethereum Alarm Clock. So we have a couple of updates today in regards to development, and then we can get start straight into the webinar. So one of the updates we have is in regards to the contract audits. So we have been working with ZK Labs, with Zero Knowledge Labs, on delivering a security audit for the Ethereum Alarm Clock smart contracts. And this has been going on for a while, but we are finally at the very last phase. So you can expect something very, very soon. Some pretty cool news and updates. So stay tuned in our media channels. And another thing we have are the updates in regards to our Ethereum Alarm Clock tools and our dApps, our JS clients. So we have released a new release of the Ethereum Alarm Clock dApp. You can check it out on our GitHub repo. And we are, as you can see, we are getting closer to release number 1. This is release 0997. And it has some pretty big changes in it. So one of the biggest changes we have is the Electron dApp. So for you guys who are not familiar with Electron, Electron is a mechanism, a way of kind of bootstrapping, packaging web applications and delivering them as executables for desktop clients. So this is something that we are very, very pumped about, because what this allows for is it allows you to run the time node natively. And what I mean by that is, instead of running the time node in the browser, you can now download the executable and run it just like any other application that you run on your desktop computer. So for Mac, this would be like .app files. For Windows, this would be .exe files. And for Linux, you have the zip files as well. So this is pretty awesome stuff. So we hope you guys test it, give us some feedback around it, and yeah, let us know. Another update we have is with the dApp is in regards to the transaction lists. So in the dApp, what we have is a thing called the transaction scanner. And in this transaction scanner, it is kind of like an explorer for scheduled transactions. And what we have been working on is optimizing some of the load times on these views, on these transaction scanner. So basically now, if you open the dApp and search for any scheduled transaction that you might have scheduled before, you can find it in a very, very fast way. So another thing we have is in regards to some of the statistics with the time nodes. We have pushed a number of bug fixes and a number of improvements to both the UI layer and the functionality. So we are very happy about that as well. And the last one we have is a number of search improvements, biggest one being you can now search, instead of just searching by transaction address, you can now search by sender address. So what does this mean? So that means that if I schedule a transaction with MetaMask, with my MetaMask account, I can now copy this address, paste it in the search, and it will give me a result of all the transactions that have been scheduled by my address, by me, right? And this is something that we consider is pretty cool as well. So let's start from scratch before we get into the Ethereum Alarm Clock and the Chronos Protocol. Some of the so what are the main differences? Let's start with why are we building this? So we're building this because we consider that scheduling is a fundamental functionality for any financial system, transactional system. We kind of take this for granted today in our phones, in our banking apps. You can always schedule a transaction to happen at a future point in time. But unfortunately, on the blockchain, being decentralized, being trustless, it gets a bit trickier. And all these transactions, they require an external trigger. And so there is no native way to schedule transactions in the blockchain in Ethereum. So what we have been working on is how can we solve this problem? How can we guarantee that a transaction will be executed at a certain point in the future? So this is the main problem we are trying to address with a lot of these things that we do here at ChronoLogic. So let's define the Ethereum Alarm Clock protocol. It is, a lot of you guys already know this, but just for the guys who are here for the first time, we'll just go through this again. So the Ethereum Alarm Clock is an open source smart contract protocol built by Piper Merriam in 2015. It has kind of died out during the 2016 DOS attacks, and we, together with Piper, we have decided to partner up and restart the development of it in late 2017. Whereas the Chronos protocol, on the other hand, it is a brand new novel protocol created by ChronoLogic, and this is basically, it started off as kind of like a test bed for all these breaking changes that we couldn't include into the Ethereum Alarm Clock because it is so close to release and this security audit that we just couldn't, we wouldn't like to kind of interfere with this, but kind of see if we can improve upon this and build something radically different ground up. So while it does have all the features, similar features as the Ethereum Alarm Clock, it is more than just a scheduling protocol. It is kind of like an evolution where we kind of consider it as a smart contract automation platform. So through this, we have tried exploring a number of other applications and interoperability kind of solutions. So some of which we'll go through a bit later in this presentation. So let's start with the similarities of the two. So the first similarity is they are both open source. So you can find both of these on our GitHub page, on the Ethereum Alarm Clock page, and anybody can use this, reuse this, and in the very open source fashion. So another similarity is that they are both smart contract based on the Ethereum platform, at least for now. The third thing they have in common is they have this second layer market. What we mean by that is we have these clients called time nodes, and they kind of compete and they try to execute as many of these transactions as they can. Right? So we can just recap the architecture. This is the architecture of the Ethereum Alarm Clock, and the Chronos protocol has a very similar architecture, but we will go through some of the differences in it. So basically, what we have is a couple of entities in this whole system. So the first one being the user. So the user's wish is to schedule a transaction at a future point in time, to run this without him bothering about it, or if he needs to schedule, whether it's like a recurring payment, monthly payment, or whether it's like a one-off payment, he wants to do this at a specific point in time, and using the Ethereum Alarm Clock, he can do this. So he would specify a destination address, the time at which this address has to be executed, and the amount he wants to send to this destination address. He would also then offer a bounty to any time node that will execute their transaction. The time node being basically the other entity that executes these transactions at their requested time period. So the user would send these parameters to the Ethereum Alarm Clock protocol, which would then deploy this scheduled transaction. This scheduled transaction then waits for the right time to be executed, at which point the time node also sees that this is the correct time to execute this transaction, and it does execute it. By executing it, we mean it just gives it permission to send all of these funds that were initially the user wanted to send to the destination. It would just release these funds and get a reward for doing so. So it is in the user's interest to schedule a transaction for a future point in time, and it is in the time node's interest to execute these transactions for a small bounty, for a small fee. Now that we have gone through kind of like the basics of these two protocols, I have with me my colleague Anthony, who is the developer here at ChronoLogic, amazing guy, and we will do kind of like a split panel for some of these differences between the Ethereum Alarm Clock and the Chronos protocol. So Anthony, say hi to the guys.
Hey, thanks, Joseph. Hi, guys. How you doing today? My name is Anthony. You might also know me as Madba03, developer for ChronoLogic, and stoked as well to be here and just assisting Joseph to go through the differences basically between the alarm clock and the Chronos protocol, based on the request from you guys. So, up to you, Joseph.
Awesome. So let's get started then. So what do we have on the left-hand side? We have the Ethereum Alarm Clock, and in this slide we will compare types of scheduling with between the Ethereum Alarm Clock and the Chronos protocol. So the Ethereum Alarm Clock is built in a way that it allows for temporal scheduling. What does this mean? This means that you can specify a certain timestamp or a certain block number in the future, and it will execute transactions at this correct time. Anthony, maybe you can tell us like what is the difference in this with the Chronos protocol?
Definitely, Joseph. So, just as I said before, in the previous webinar, I said the Chronos protocol is the alarm clock on steroids. So it includes in itself everything the alarm clock can do and even more. So beyond just the temporal scheduling, it also has the conditional scheduling, and what that is it also listens to events from other contracts on the blockchain, and based on the presence of those events, and these events might either be the state of a contract or a change in the state of a member of a contract, and based on that, it decides whether the transaction can be executed or not. We have been calling this the conditional scheduling. If this, then execute, basically. So this increases the ability of the Chronos protocol beyond just what the alarm clock can do, which is wait on a particular time.
Awesome. We are very stoked about this exact feature, and we feel that this will be a great distinction between the two. So thanks for clearing this up, Anthony. So what we have next is the usage of these protocols. So why would a person use the Ethereum Alarm Clock protocol, and why would they use the Chronos protocol? What would they use it for? So the Ethereum Alarm Clock, as we said, it is for time-based triggers. So this could be like one-off payments, recurring payments, payrolls, charity contributions, monthly, yearly, crowdfunding contributions, and also scheduling some, let's say, smart contract method triggers. This is something that we have talked a lot about, but we would like to get into some of the new use cases we have with the Chronos protocol.
So with the Chronos protocol, above and beyond what the alarm clock can do with time-based triggers, it focuses on adding the event-based triggers. And the use case of this includes the DEXs, the decentralized exchanges. We also have stop loss triggers. So with all these exchanges, you could based on the price feed from the exchanges, which is on the blockchain, you could schedule your stop loss. And also we have mining pool exchange interactions. So what mining pool exchange interaction is with miners, you receive your funds or your payment in trickles. So miners set a minimum of probably 1 ETH or 0.5 ETH to receive their payment. So you could set up a scheduling transaction which checks the balance and says, okay, I have up to 5 ETH. Now I can send this to the exchange and get my payment for whichever token I want to buy. As well, you could do that by watching the prices from the dexes and say, okay, the price is right. No matter the quantity of ether I have, I would love to sell them right now. So that's just those are the additions that the Chronos protocol brings to the scheduling system.
Awesome. Another thing we would like to note, guys, if you have any questions, be sure to leave them in the question box below. We will go through the questions at the end, and then just kind of once we have everything defined, because we have a couple of other slides, and we might cover some of those in these slides. So thanks for explaining the event-based triggers, Anthony. So another change we have is state storing. What does this mean? This basically state storing, we define it as how do we store all these variables that say if a transaction has been executed, at what time it has to be executed, and these kinds of things. The Ethereum Alarm Clock stores all these variables in the smart contract itself, and this is a great way. It's a very simple way. It is quite costly though, so we have done something different with the Chronos protocol.
Yeah, we have. As Joseph just said, it's quite expensive storing so much information to the blockchain. Presently, with the alarm clock, we have the optimized value of about 500,000 units of gas per scheduling transaction, and that is quite expensive based on the fact that if you then add in other factors, you realize that you could be spending a whole bunch of Ether just to schedule a transaction. But what does the Chronos protocol do? With the Chronos protocol, we include the IPFS, which is decentralized storage, such that the information which you'd rather have stored on the blockchain with the alarm clock, you can easily store in the IPFS, and you can be sure of the integrity of such information. And this brings the cost of scheduling a transaction to as low as 150,000 units. So this is more than 50% slash in the cost of scheduling a transaction, basically.
Okay, so let's get to the next point. Next point is claiming. So for the guys who are new to the Ethereum Alarm Clock protocol, claiming is basically a way of saying of if the time node sees a transaction that has been scheduled on the blockchain, it would say, "Hey guys, I want to be the one who will execute this transaction when the time comes, and I guarantee that this transaction will be executed by providing this deposit," for example. So we have two different ways of going about this. In the Ethereum Alarm Clock, we have the on-chain way, where the time nodes, once they see a transaction that has been scheduled, they immediately apply, okay, I want to be the one who will, they immediately try to claim this transaction. They say, I want to be the one who will execute it. But if in the same block, if a number of time nodes does this exact action, only one of them will succeed, and this is called a collision, a transaction collision, and and basically only one of them will succeed in claiming this transaction. In the Chronos protocol, we have another option as well.
Yeah, so with the Chronos protocol, right? With the present proof of concept which we have, the claiming is done on chain, right? With something we call the priority queue. The name was coined by our own Logan Seda, who's been the shotgun on building the alarm clock. And what the time node, what the queue does is to align the time nodes based on their stake, and this stake is no longer in only Ether but now in Day, and this affects you with our Day token holders, in the sense that this brings more economic value to the Day tokens. Also, in research, we have the possibility of having the queue off chain, basically, by having our time nodes communicate with each other in a peer-to-peer system, thereby reducing the cost of actually executing the transactions. I would like to add one other thing, which is that on the alarm clock, the stake for the claiming is non-refundable, basically, but we're working on the possibility of making it refundable with the Chronos protocol.
Well said, Anthony. And let's go over to the next point, which is executing the transactions, executing the unclaimed transactions, because once a time node claims them, they will be the one to execute it. And if they don't, they will have a fee, and then it will be free for other time nodes to execute these. So what we have in the Ethereum Alarm Clock, basically the way of kind of deciding who will execute this transaction is kind of similar to it is also on chain. So it is kind of similar to the way the claiming works as well. If multiple people try to execute the transaction in the same block, only one of them will be able to succeed. So it has a chance of execution collisions, and this is something that we have tried to avoid while building this new Chronos protocol.
Yes, actually, this is one of the main reasons Logan came up with the priority queue, the execution collisions as well as the claiming collisions, right? And right now with the Chronos protocol, we have the priority queue on chain, and which is arranging the time nodes based on their Day token stake. We're also working on the off-chain model, which still accounts for the total Day token stake of each one of the time nodes, and uses that to decide the priority of each one of the tokens. And the main point of the priority queue, as I said earlier on, is the fact that it takes out the possibility of collisions. Now, this is very, very healthy for the ecosystem, in the sense that the amount of gas wasted to collisions is equivalent to or is part of the loss which the time nodes incur, and has to come from the time bounty which the scheduler sets when creating or scheduling the transaction. So it reduces the overall cost of the ecosystem as a whole.
And the last point we have here is the gas cost. So this is something that plays a big role in the whole Ethereum ecosystem, as how much does it cost to schedule one of these transactions? How much gas does it cost? So in the Ethereum Alarm Clock protocol, the current gas cost per scheduled transaction is about half a million gas. And with the Chronos protocol, so we have lowered this.
Yes, we have actually. In the present proof of concept, which is only an alpha, right, which is still far from completion, we reduce the gas cost from 500,000 to approximately 200,000, which is more than 50%. And we're still looking at the possibility of reducing it to as low as 150,000 once we implement the off-chain part of the whole process itself. And this is presently in research phase, but we are actually making headway in the research, basically.
Awesome, guys. So that will be it. In terms of these this round that we did, comparing one to another. Hopefully, you guys have a kind of like a better idea of some of the differences between the two. Let's talk a little bit then about crypto economics here.
Yeah, thank you, Joseph. Okay, so in the previous webinar, Peter spoke about the economics of the ecosystem itself, the economics of the time nodes. And for those who missed it, we have the link to the blog post which Peter made about that in the slide as well. So the main focus of the economic study is to do a calculation or to calculate the effect of the prices and the price fluctuations and the bounty and all the different components of the scheduling process. Now, what this affects is how profitable will it be for the time nodes to execute transactions, and how expensive will it be for the users to actually schedule transactions. From our present calculation, we have that at least $7 per time node per month is what is the minimum target of profitability. This was chosen by using the calculation or the price of the Dino node, which we have running in Heroku. And the cost of running that for a month is actually $7. So I would advise you guys to go further into the blog post which Peter wrote on it to have a good breakdown of the economics. He has a chart in there which shows or explains the present state of the Ethereum Alarm Clock, the version 1. Now, please take note that this doesn't refer to the Chronos protocol because this is still very much under development, and so we don't have all those values for it yet. So that's about the crypto economics of the time nodes. So finally, I would love to speak about the open problems which we've been having so far, or which we've been trying to deal with so far with building the alarm clock and the Chronos protocol itself. The first is the transactions collision. So we've been mentioning collision, claiming collision, execution collision. This is the core of the collisions. With Ethereum, the EVM is synchronous in the sense that only one transaction happens at a point in time. So all the transactions which go into each block are queued one after the other. So if two different transactions try to do the same thing within that block, what happens is one succeeds while the other reverts. And the problem with that is upon reverting, the gas cost is the gas that was sent along with that transaction is burned up. And the reason for the burn is that to avoid spam transactions, you have to burn the cost. Is a incentivization slash disincentivization system of Ethereum itself. So this has been one of our major focuses with building the Chronos protocol on how to minimize and mitigate as much as possible. Now we doubt we'll be able to reduce it to zero, but 0.001 is very, very sufficient by the look of things. Next is the gas price and dynamic gas costs. As we've seen from the Ethereum network, you could have within the period of 2 hours having the gas price fluctuating between probably 2 GUA and 10 GUA. As at an hour ago, the gas price was around 10 GUA, the average gas price, and I'm pretty sure that by now this could have changed. Now, why does this affect us? Basically, because of the level of the fluctuation, you cannot be certain about what the value or the average value of the gas price in the next few hours or the next few days, which you're scheduling your transaction for. So as a result of that, when the time node attempts to execute the transaction, the gas cost might end up being too little, thereby making the transaction fail. This is a big problem for, this is not really a problem for the time nodes, more a problem for the schedulers. And we've been working on ways to actually account for this. We've had different brainstorming sessions where we accounted for different possibilities, different game theories, as well as different algorithms, Boolean algorithms, to try to account for this. So those are the two major problems, which well, not just the Ethereum Alarm Clock or Chronos Protocol problems, but general problems of the network itself. So I guess this brings us to the end of the webinar. Here are links. Remember to follow us on the different social media links, Twitter. You can also go to YouTube to view all our past live streams, as well as this one. This will be uploaded in few hours to a day maximum. And thank you all for listening. Now it's time for questions and answers, basically. So please put your questions in the question box and we'll try our best to answer them.
Awesome. We already have a number of questions. Thanks for the presentation, Anthony. So let's go through Harold Howard. So he says, "Oh, when will the Chronos protocol be ready?" So so the Chronos protocol is still in the research phase. We are still we have a number of functions of it separately working as a proof of concept, but we have run into a number of issues which are not just they're not like scheduling specific or chrono specific or Ethereum specific, but we have found that basically the whole Ethereum community and basically the whole blockchain space is dealing with similar issues with, and that's why they are building different second layer solutions and some other off-chain markets. So we are in the same phase. So there is no ETA at this point, but stay tuned on our social media, and you can see more about it as we progress. But the Ethereum Alarm Clock is very, very close to release, so we are very happy about that. Thanks for the question, Harold.
Yeah. Thank you, Harold. Let me take the question from Mr. Swiss. You're trying to, but time nodes stay off chain. Okay, you asked the question first. You said, is it true the EAC is for on-chain requests while time nodes are off-chain execution of those requests? And then you asked, but time nodes stay off-chain even in Chronos protocol, right? So, Mr. Swiss, the way it works is unless you send a transaction on chain, the transaction cannot be executed. So what we are trying to do is to ensure that all other aspects of the Chronos protocol stay off chain, while the final transaction, which is the sending or the executing of the transaction which the scheduler set up, is sent on chain. So it's a mix of both. As much as possible, more of the parts should be off chain and just the sending of the final transaction. And okay, so there'll be two parts at least that have to be on chain, which is the staking of the time nodes, staking and withdrawal of the time nodes funds, and the actual execution of the transactions. I hope that answers your question.
Awesome. I can take the next question. We have a question from Martin Devra. I hope I didn't butcher the name. Sorry. So Martin asked, have you thought about developing a custom betting module or Ethereum futures market module that uses the Chronos protocol for pricing oracles, for example? That would be awesome and high in demand if done right. Maybe an idea. Thanks for the question, Martin. So as with the Ethereum Alarm Clock, we are using a similar development methodology with the Chronos protocol. We want to build this Chronos protocol in a way that is open source and community beneficial, and we want to make it as modular as possible. So I'm not sure if we will be going to any specific building using this Chronos protocol for any specific purpose, but we try to build it as versatile as possible. And then other developers, anybody who wants to build on top of that, they can use this. And we are very much looking for people and partners and who will want to partner up with us and build some amazing solutions on it. So thanks for the question. I think that would be definitely one of the use cases for the Chronos protocol. And we really hope that people will kind of adopt this protocol and build even build these solutions and even better solutions on top of that.
Great. Thank you, Joseph. So I think I answered Mr. Souza's question already about the execution relying on off-chain. So I'll just take the next one from next level. EAC will be first on mainnet and Chronos protocol later. Yes. Yes, the EAC, once audits are completed, will be deployed to the mainnet, and then the Chronos protocol will join later on when it's ready, basically. Okay, so I think that should be all.
Yeah, so we can slowly wrap this up. Thanks, guys, for all the questions. Thanks, guys, for the lovely interaction. Hopefully, now you have a better understanding, a clearer kind of vision of the Chronos protocol and the Ethereum Alarm Clock, how they kind of bind together, and how we used basically all the knowledge we've gathered building the Ethereum Alarm Clock protocol into building something that might potentially be even more revolutionary. So for now, we are looking for people who will use the Ethereum Alarm Clock. It is very close to the mainnet release. As soon as it hits mainnet, people can build amazing things with it. And stay in tune for all the new updates with the Chronos protocol, because the Chronos protocol will bring something even better. And hope you guys enjoyed this live stream. And again, thanks, Anthony, for being my co-host. And talk to you guys in the next live stream.
Thank you, guys. Thank you, Joseph, for having me.
Take care, guys.